So Unit P covers a lot of material. This is considered a lot of algebra basics that we should know, or we will know after we go over it. So if you turn to that first page, it's working on the real numbers and their properties. So we have some objectives of what we should be able to do when we're done with this first section. If you want, you can take the staples out. That's totally fine. This is for your notes, so you can take them however you'd like. So classifying sets of numbers. Natural numbers, think of them as your counting numbers. Okay? If you need pencils, they're up here as well. So like 1, 2, 3, 4, and so on. It is only the positive counting numbers. It does not include 0. A whole number is 0 and the counting numbers. Think you can have a whole lot of nothing. Okay. Integers are positive and negative whole numbers. So think counting numbers, positive and negative, and 0. So when we work on adding and subtracting integers, those are just your basic multiplication, addition, subtraction facts. No fractions, no decimals. You're good. No, don't be sorry. Rational numbers, go ahead. Rational numbers you can write as a fraction. You can write as a decimal that stops, or a decimal that repeats. Okay? But if there's a number that goes on forever and doesn't repeat, like pi, that is irrational. Any square roots of numbers that you cannot break down into perfect squares, those are also irrational. Okay? So this is just a chart showing you that natural numbers are integers and rational numbers. Irrational numbers are its own thing. No, if it's irrational, it is not rational, integer, whole, or natural. Okay? Anytime you have fractions, it's either going to be rational or irrational, none of the rest. Unless you can actually divide those numbers. If it's like 6 divided by 2, oh, you can get a 3 out of that. Okay. Questions so far about the breakdown of what is real, rational, irrational, all that stuff? Okay. Now, if we're writing 7.45 as the ratio of two integers in the lowest terms, this one is kind of complicated because that 0.45 is repeated over and over and over again, right? So this means, I'm going to write in blue, 7.454545, and it keeps on going, right?
I need corn and I need the waffles to the office, please.
So when we're trying to solve something like this, that's equal to 100 times some number. Okay. Try to talk with the people next to you to see if you can figure out how to solve something like that and make it a fraction without any decimals while I take attendance. It's okay, talk through it. It's okay if you're wrong, it doesn't matter. We're just trying to have a discussion. See if you can come up with a fraction that gets really close to that. Go ahead, use your phone as a calculator if you want, or I have some basic calculators up next to the pencil sharpener. Anybody find something close? All right. Well, let's get rid of that. Let's assume that this is equal to x. This is our number, right? If we have this 745.4545 repeating equals 100x. That means I multiply by 100 on both sides.
What does that mean?
All I did was multiply by 100 on both sides.
Oh, yeah.
That's it. Okay, that makes it kind of better. But what if I take this new piece and subtract the original? So this is new, this is the original. If I do new minus original, that would give us 745.45 repeating minus 7.45 repeating is equal to 100x minus x. Now that looks really complicated. Why in the world would we do something like that? Because that would get rid of my repeating decimal. Both of them have 4545454545 repeating. And when I subtract them, it gets rid of all of those repeating things. So essentially what we're doing is 745 minus 7. Because the 45454545 stuff after the decimal goes away. So that would be 738 equals 99x, because 100x minus 1x is 99x. Now how do I go about solving something like that to get x by itself? What do I have to get rid of? The 99. And right now it's being multiplied, so we got to divide by 99. Hey, look, now I have my fraction that's equal to x. So to do repeating decimals, you're assuming that that repeated decimal is equal to x. You're going to multiply both sides by 100 and create a new equation. And then you do new minus original to finish solving. Now this is the hardest of them to convert. Okay? What questions do you have about the first one? Okay. Anybody need a little bit more time to finish writing down? Okay, not a problem. If I'm going too quickly ever, just tell me to slow down. Okay. What were the natural numbers? In your own words, what are natural numbers?
Numbers that haven't been touched.
Okay. Think counting. Right. So of those numbers up there, remember it's always positive counting numbers. What numbers are natural? 7 and 18.
What about 0?
0 is not included in natural.
Okay.
It is a whole. 0 is a whole.
Oh.
Remember, think whole lot of nothing. So this means 0 and positive counting. What I like to do is write descriptions of the things that I'm asking, just so it's a nice little mental note later. So this includes 0, 7, and 18.
Oh, what does it say above count in parentheses?
POS for positive,
Okay.
because I'm lazy and didn't feel like writing the whole word. Integers are positive and negative counting numbers. So, what are my integers? Zero, 7, 18.
What does it say between the I count? Does that say?
Plus or minus.
Oh, plus or minus.
Is there anything else that might count as an integer up there? Look carefully. Mm-mm. Because the 2 isn't a perfect square. Good thinking, though. Nope, pi's irrational. Keeps going on and on and on and on. Nope, because it's still a fraction. You can't really change it into anything else. What's something that you can go from a fraction to a regular number? Negative 6 over 3. Because you can do negative 6 divided by 3, that can also be an integer. Because negative 6 divided by 3 equals negative 2. So anytime you have a list of numbers, go through and try to simplify them first. And if you can't simplify them, that's how you know that they might be something else. It might just be a fraction, or it might be a really messy, long decimal. Okay? Rational. These are fractions, repeating decimals, decimals that end, and integers. So that's a whole lot of stuff that it could be. Rational is like this really big net that we're casting, and it has lots of numbers in it because it includes natural, whole, integer, and fractions and decimals that stop or repeat. So, what numbers would be rational? Negative 17, thumbs up or thumbs down. Okay? Negative 5? Yep. Negative 6 over 3. Yep. Negative 2/3.
Oh, yeah.
Yep. 0. Yep. 5 over 12.
Yeah.
Yep. Remember, think any fraction, any regular counting number, positive or negative, and anything that we can reduce that doesn't have this really long, messy, non-repeating decimal. 1/2? Yes. Can we take the square root of 2 and get a nice whole number out of it? Like something times itself equals 2. No. Root 2 is not rational. It is actually irrational. What about pi? What did we say pi was? Irrational. Because pi, the digits of them, keep going on forever. And they don't repeat. What about the square root of 35? Is something times itself equal to 35? No. So that is also irrational. What about 7? For rational. Yep. And so is 18. So, irrational numbers are decimals that never end. You can also think messy square root. Questions? Do you remember seeing this stuff at some point? If no, that's okay. So you will have a list of numbers that you're going to have to classify in this way, almost exactly in this way. Okay. All right. Any questions for number 2, or can I move on? Okay. Exponents. An exponent tells you how many times something is being repeated. So its base is the number that has that exponent on it, and the exponent is that number written above. It tells you how many times that base is repeated. So 5 to the third means 5 times 5 times 5. So 5 times 5 is 25. Times 5 is 125. On a calculator, I promise I'll have them like unpacked and batteries in there next time. In the calculator, you would do 5, the little exponent button, and 3. So this is how you do it on the calculator. Or you could just do 5 times 5 times 5. That's totally fine. For number 4, because it's in parentheses, it's telling you the stuff inside those parentheses is what is being repeated. So this is telling you -3 is being repeated twice. A negative times a negative is a positive. So what's -3 times a -3? 9. Positive 9. So when you put this in a calculator, you need those parentheses. Because without the parentheses, like number 5, it's saying the opposite of 3 to the second. So this means a -3 times 3, because 3 is the only thing being repeated, the negative is not. So this is -9. So if you do -3 exponent 2, that doesn't have parentheses, except for like the little negative button on the calculator. So what does number 6 mean?
Oh, wait.
That's number 5, but yes. Number 6, what does that one mean? Yeah, -2 is the one being repeated. That's fine.
Pardon this interruption, students. Upward Bound meeting today in the Welcome Center. Again, there is an Upward Bound meeting today in the Welcome Center.
-2 times -2 is? Times -2?
8.
-8.
Oh.
The 8 part was right. It was the negative that you were missing. So again, you would need that negative in there too, exponent 3. Biggest takeaway from this, with parentheses, I'm going to put exp for exponent. An odd exponent has the same sign as the inside number. Nope, you're good. Just leave the door open a crack. But an even exponent is always going to be positive. Because if we had, like for this one, if that was negative 2 to the 4th power, or the quantity negative 2 to the 4th power in those parentheses, a negative times a negative is a positive, times a negative is also a positive. When there's an even number of negatives being multiplied, it's a positive number. Does that kind of make sense? But if it's
Can you say that again?
yes, absolutely. If it is an even number of negatives, a negative times a negative is a positive, those even numbers cancel out that negative. So if we have 2 negatives, that's going to be a positive. If we have 4 negatives, that's going to be a positive. If we have 6 negatives, they each have a pair to get rid of that negative. But if we have an odd number, we don't have enough pairs to have them all cancel. But not in that way?
Yeah, you did wrong.
Yeah, it's okay. We still okay here? Awesome. Anybody need a little bit more time to write any of that down?
Just one more. Like,
Perfectly.
30 more
It's fine. Let me know when you're ready. The next one, you're probably going to laugh at my explanation, but it's okay. All good? Okay. Inequalities. How many of you get confused which one's bigger, which one's smaller? I do sometimes too. So what I like to do, I'm going to choose green because this makes the most sense. Treat it like an alligator. Yep, it eats the bigger number every time. And if you need to draw the little alligator on it, go ahead. I know it seems silly, but that's okay. The alligator is always eating the bigger number. So the wide part of that inequality is always bigger. And because high school people are normally mean, the smaller things, you're making fun of people, you're pointing and laughing. It is pointing at the smaller piece. Okay? I'm not saying it's right, I'm just saying it's what's done. So, number 7 through 10 is asking us, is this true or false? Is 5 bigger than 0? Yeah, that's true. Yes, 5 is bigger. With the negatives, think about negatives like owing money. Would you rather owe $2 or owe $3? You'd rather owe 2. Negative 2 is actually bigger. Is that what that inequality says? No. This is saying that owing $3 is better than owing $2. Now, if my account showed me negative 3, that's not good. Number 9 is 2 that inequality to 3.
What does the line mean under it?
It means it's allowed to equal. Good question.
No.
Isn't that greater than or equal to?
In this case, it would be 2 is less than or equal to 3. or you can read it as 3 is greater than or equal to 2. It doesn't have to be equal, it's just saying it's an option. So is 3 greater than or equal to 2? Yeah, that's true. 3 is bigger. Is 4 less than or equal to 4? True. And the reason it's true is because of that piece underneath. If it did not have that line, it would not be true. Okay? Questions on inequalities? Okay. There are a few different ways to show sets. You can list all of the elements in that set, meaning you put, I like to call them fancy brackets. Easy way to write those for those of you that might be struggling. It's like this, and a point in between. Or you can just go for it and make a little squiggle, that's fine. And then you list every single item that's in there, separated by commas. It's just saying these are all of the possible options for your answers. Now, for this, you can, again, list them all, or you can describe it in terms of set builder notation. I'm not super worried about that for now. We'll get to that later in other chapters. A set with no elements is empty set, null set, or it's a 0 with a line through it. It means it doesn't work. If you get an answer of like 5 equals 7, that's not true. Nope, empty set. Union and intersection. Union, think union starts with a U, so it has a U. It's saying anything that's covered in A or B or has them combined. Intersection means only the things that overlap. Intersection, overlap. Interval notation. Has anybody seen interval notation or like have heard of it before? Okay. So interval notation is how you show where something starts and where something ends, and if there are any gaps in between. So open interval, let's say all of the numbers between A and B. I'm going to put in different numbers in there just so you can actually see what the heck I mean. If I say it's between 1 and 3, X is a number between 1 and 3, but there's no line underneath, so that's saying it doesn't include 1 and doesn't include 3. So if I were to graph that on a number line, I've got a 1, I've got a 3. They're open because it is not allowed to equal, but it's every little thing in between. I can write that in interval notation by saying 1, 3. It's saying this is where it starts, this is where it ends, and it does not include either of those numbers because it's a parenthesis. Okay, you can get rid of it. Now, a closed interval is saying it goes from here to here, but it includes those endpoints. So if we use those, actually, I'm going to use different numbers. Oops. Give me a number.
5.
And another. Okay, 5 and 7. 5 less than or equal to X is less than or equal to 7. X is smack dab in the middle of those things and can equal 5 or 7. So that's saying on a number line, 5, 7, we're allowed to equal, and it's everything in between. This is saying a bracket tells me it's allowed to equal. Bracket means can equal. It's closed. And this is going from 5 to 7. So again, 5 is the start, 7 is the end, and the brackets include those numbers. You can also have them as one-sided things. Let's say it included 5 but didn't include 7. You good? Okay. That means 5, heck yeah, we can equal that. 7, not so much. So it includes 5, but doesn't include 7. It's showing it starts at 5 and goes to 7, but 7 is not included in that whole thing. So that's why it has a parenthesis. I'm going to pause there for a second before I get into the break of those. What questions do you have? Have I completely lost you yet? Okay. Go right ahead. Yeah, snacks are back there if you'd like some. Just don't make a mess. I also have an electric kettle and tea. I have mugs that you can like keep in here if you'd like to make some. There's honey and sugar over there too. But once it's gone, it's gone.
Yeah, that's like the first time I've heard a teacher have honey and sugar for the
Yeah.
first time.
Brought it in today, which is why it's still there.
Yeah.
All right, let's talk about gaps. Actually, before we talk about gaps, let's say everything's included. It could be any possible number. Let's say it's the entire number line. Whoop. This means it goes from negative infinity, which means the smallest possible number you can ever think of, to positive infinity, which is the biggest possible number you could ever think of. That means it includes everything. And because negative infinity isn't really a number, it can't touch negative infinity. Think Buzz Lightyear to infinity and beyond. There's a beyond, so that's why it's a parenthesis. I know it seems really silly, but these are little things that you can think of to help you remember. Okay? Now, let's say there's a gap. Tell me a number to exclude because we don't like it.
3.
Sure. If x cannot equal 3, that means at 3, there's a hole, but it's everything except 3. This means it starts from left to right. It starts at negative infinity, keeps chugging along. As soon as I hit 3, I have to jump over a gap. So it includes everything up to 3, but is not allowed to equal. The U means there's a gap. We got to get around that. And it starts again right past 3 and keeps going until infinity. When these two numbers are the same, it means there's a gap at that specific number. We'll see more of that in like unit 1, 2, and 3. Sideways 8. All right, hit me with your questions.
So, like, in questions, are we gonna have to write them out? Like, do you know what I mean?
In terms of interval notation, yes, eventually. I don't remember what things I put where for this one, so I think I tried to make them pretty basic for the first few types, but if you get stuck on something, let me know. Okay. All right, absolute value. Whatever is inside the absolute value, it's saying simplify everything inside, and then your answer of that is the positive version. Okay? It does not mean change every sign. It means simplify, then make it positive. So what's the absolute value of 4? Just 4. What is the absolute value of negative 4? 4. How do we solve number 13? Okay, so we're going to simplify inside first. Think of absolute values like a big set of parentheses where you do the stuff inside first and then make it positive. So negative 3 plus 1 is negative 2, but you're still taking the absolute value of your overall answer. So the absolute value of negative 2 is 2. What if, it's like a bonus, negative absolute value of negative 4?
Positive. Hold on, I was just looking at this. I was just doing this problem like yesterday, dude. I was doing
Okay. If I didn't have this, and I just had that, what is the answer here? 4. But because this is outside of parentheses, that still has to stay there. Make sense? So anything outside of parentheses, it's like another step where it's like negative 1 times the answer of that stuff. Okay, because you might get something like that on Delta Math. All right. Still okay?
Yep.
All right. Yeah, basically absolute values just show distance between things on a number line. Order of operations. You've probably heard of PEMDAS. Please excuse my dear Aunt Sally. I don't really like it that way. Parentheses is absolutely first. But you have to treat fraction bars and absolute values as grouping symbols. It groups things together. Okay? Then you're going to have to do exponents. So think of P/G, parentheses / groupings. You're going to do first.
Lorraine Redkettle to the office, please. Lorraine Redkettle to the office.
Multiplication and division, you are doing from left to right, whichever shows up first. You do not always have to do multiplication first. You read it from left to right. Okay? Whichever one shows up furthest on the left, that's what you do first. Same thing with addition and subtraction. Okay? Always from left to right. And that's like a really important thing to note about the multiplication, division, and addition and subtraction. So number 14. What are we going to do first? Exponent. Awesome. So what I'm going to do, I'm going to copy the rest of this stuff down. What is 2 to the 5th power? So let's work through it. 2 times 2? Times 2? Times 2?
16.
Times 2.
32.
There we go. Now we have multiplication or addition. Which one do we do next? Yep. 3 times 32. 96. There we go. Plus 4. What is 96 plus 4? 100. Which is what I hope you all get on all of your Delta Maths combined. So far, so good. Okay. Number 15, what do we do first? Parentheses. We're going to work inside there first. So copying down 5 minus stuff in parentheses to the second. What is 3 minus 1? Good. Now what? Exponent. This means 2 times 2 because it's multiplying it by itself. So we have 5 minus And what is 5 minus 4?
1.
1. Ta-da.
Oh, man.
Making sense? Little by little.
Jada Peters to the office, please. Jada Peters to the office.
Fractions. To add or subtract, you have to have the same denominator. To multiply, you multiply straight across. To divide, there's a 3-step process. Keep, change, flip. Keep the first fraction, change it to multiplication, flip the second fraction. Dividing is the same thing as multiplying by the reciprocal. Reciprocal means flip that fraction. Okay? So, addition for number 16. These need to be the same. If you struggle with finding a common denominator, you can always multiply by the other denominator on top and bottom. Now, it's not always going to be the easiest, but it will always work, and then you'll have to reduce after. In this case, it is the easiest. So if we multiply this one by 2 and this one by 3, why are we allowed to do that? Why are we allowed to like randomly multiply stuff by different numbers? Let me focus your attention here and here. Because we're multiplying by the same thing on top and bottom. What is 2 divided by 2? 1. We're technically multiplying by 1. We're making them easier to work with, but it's technically the same thing. So here, we have 10 over 6 plus 9 over 6. Hey, look, now that they match, this means 10 plus 9 all over 6. Which is 19 over 6. I prefer improper fractions. That's it. If you can reduce, reduce. This one doesn't reduce because 19 is prime. Make sense? Okay. Subtracting, same idea. You could multiply the first one by 3 and the second one by 6, but what would be easier? Just multiply the second one by 2 on top and bottom, and then those denominators will match. So we have 5 over 6 minus 4 over 6. Hey, look, they match. So now we have 5 minus 4 all over 6, which is 1/6. Now, obviously, you don't have to show this part. You can just go straight to there, but it's just to show you why that works. All right, multiplying. Ow. You can multiply straight across, or you could reduce first. You could reduce those cross things. Because if you think about it this way, this is essentially doing 4 times 15 over 3 times 8, right? If we look at 4 and 8, what can I divide both of them by? Or 4. Guess I should probably put that. Divide 4. Okay, so that gives me 1 and 2. Do you agree there? Also, if you want other colors, I have highlighters and like colored pencils and stuff in there. You are more than welcome to use whatever you want. Okay. Now over here, if we look at 3 and 15, what can we divide both of those by?
3.
Yeah, if we divide by 3 and divide by 3, we get 5 and 1. So 5 over 2 is our answer. or 60 over 24, and then we'd have to divide by its common piece. This was when we just multiplied straight across instead of reducing first, which is totally fine, and then you'd have to reduce after. Okay? All right. Division. What were the three things? Keep, change, flip. Keep, change, flip. If you know the Missy Elliott song, put the thing down, flip it, and reverse it. That's what I think of anytime I think of dividing fractions. Again, I know it's super weird, but this is what my brain thinks of. And now you're going to be stuck singing that to yourself. All right, so do we want to simplify first or just multiply then simplify? I don't care.
Simplify.
Okay, cool. Hey, look, those are things I can divide easily. So when I do that, I can divide that by 5 and that by 5. So that makes a 1 and a 5. And when I multiply straight across, I get 10 over 9 as my final answer. Or this would be 50 over, whoop, that should be 45, not 40. I promise I can do math. Which equals 10 over 9. Still okay? Kind of, sort of, maybe? You're good. Substitution. I have this whole complicated expression, and I'm like, hey, look, this letter is equal to this number. I promise it's not as bad as it looks. This just means replace the 5 in place of the x. So if I copy this down, and instead of x, I put parenthesis 5, parenthesis, and I copy everything else exactly as I see it. All I did was replace each of the x's with a parenthesis 5. The reason I make sure I put the parentheses in is because if I had a number and a letter right next to one another without a sign in between, I need to remember to multiply those, not to like randomly make a bigger number. Okay. Where?
Say that again?
Absolutely. So all I did was replace every single x with a 5, but I used parentheses. Because if I had, for example, 3x, I don't want to randomly make that 3, 5. I want to make that 3 times 5. It's the reasoning behind it, okay? In this case, it wouldn't have mattered because nothing is being multiplied, but that's beside the point. What am I going to do first? Parentheses. So these things are actually grouped together. So what would I do there? 9 plus 5 is? 14. And then I copy everything else exactly
Danica Smith to the office,
as
please.
I see it.
Danica Smith to the office.
Now what?
Or you could divide which by 7.
Yes, because we have a grouping symbol. Those brackets are still considered parentheses. So we've got 2. Now that it's just one number, I don't need those parentheses anymore because I already have symbols everywhere else. Now I've got multiplication and subtraction. Which one am I doing next? Multiplication. So 6 minus 5. 1. And because I'm mean, what if we have a couple different letters? Absolute value of 2 minus 2 over negative 2. Hey, look, I can use parentheses again, but in this case, it still didn't matter because things weren't being multiplied. What do you want to do first?
Absolute value.
Yeah, we can do the absolute value first. Absolute value of 2 is 2 minus 2 divided by negative 2. Now what?
The exponent?
No exponents?
Or the,
Fraction.
yeah, fraction?
Yep. We're going to do that fraction next. Because that fraction means divide. So here we have 2 minus negative 1. The answer of that division is negative 1. I have minus the answer of that division. What happens when it's minus negative? Plus. It means the opposite of subtracting, which is adding. So 2 plus 1 is 3. Questions? I know that the section P1, actually all of unit P is going to be all over the place because it's like, here's a little bit of this and a little bit of that and a whole bunch of that because it's like a preliminary chapter and there's not really a great progression to it. So I'm sorry for how much it bounces around. Any questions on anything from P.1? Okay. Let's work with exponents. We've already worked a little bit with the basics of exponents. Negative exponents means you want to flip that fraction. Anything that has a negative exponent, you have to change its level to become positive. And by level, I mean in the numerator or denominator of a fraction. For instance, if I have 5 to the negative second over 3, let's say 3 to the 4th, because why not? This is the one that has a negative exponent. So that is the one that needs to move. So instead of being on the top, we still have 3 to the 4th in the bottom, because that one was happy down there. But this becomes times 5 to the positive second. And because nothing's left up top, we always have a placeholder of 1. 1 is your placeholder. We okay with that? Same thing is true if we have a negative exponent in our denominator. We can move it up to the top to become positive. Okay? So, negative 5 to the negative second power. This negative, that's okay. That negative, not okay. We don't want negatives in our exponents. The negative in the exponent means we got to flip it. So to do this, we still have a negative 5, but it's a 1 over negative 5, and now it's to the positive second. Or another way to put that is 1 over negative 5 to the positive second. Both of those mean the same thing. Okay? What does this mean? Here, I'll zoom in for you. This is 1 over positive 25. Yeah, we're getting there. It's fine. 5 times 5, 25. Negative 5 times negative 5 is also a positive 25. Remember, negative and even makes it a positive. Now, number 2 would be different. Number 2 is saying that only the 5 is being flipped and that negative is staying out in front. So this means negative 1 over 5 to the second. Now that is negative 1 over 25. Okay? 0 as an exponent is kind of weird. It's saying you have 0 groups of things, but you're still going to have something. You're going to have 1. Anything to the 0 power equals 1. Reasoning. If I have 8 to the 5th over 8 to the 5th, you can subtract those exponents when they're on different levels. This means 8 to the 5 minus 5, which is 8 to the 0. But what happens when I divide something by itself? That equals 1. That's the reasoning behind an exponent of 0. It's saying it's 0 groups, things cancel out, but you're just left with 1. All right. Fractions to an exponent. Again, unhappy exponent. That tells me I have to flip everything inside to make that a positive exponent. This means 3 over 2 to the positive 3. Unhappy exponent means I flip it. I'll show you another way to do it in a second. Okay? Reasoning behind this is saying 3 halves is repeated 3 times. That means 3 over 2 times 3 over 2 times 3 over 2. But we don't want to have to write it out every single time. How many times is 3 repeated? 3. How many times was 2 repeated? 3. What's even cooler about this, when it's written this way, I can put little exponents of 1, because when there's no exponent, it's an exponent of 1, and I can distribute the 3 to all exponents inside. That's what that means. But you have to write the exponent in. It's not 3 times 3, it's 3 to the third. It's not 2 times 3, it's 2 to the third. Okay? Now, what is 3 times 3 times 3? 27. And what is 2 times 2 times 2? Ta-da! All right, don't write this next thing down. I'm going to show you another way to do it, and if you want to write it after, great. I could have done this an alternate way. I can put this exponent of 1 for both. And I can multiply the negative 3 to both. This would give me 2 to the negative third and 3 to the negative third. Are we okay with that step? Uh-huh. And because both of these are unhappy, that means we're flipping both of them to its opposite level. 3 to the third and 2 to the third.
Oh.
If you want to write it down, go ahead. So we still get 27 and 8. The frustrating part about exponents is you can treat them so many different ways that there are so many correct ways to do it that sometimes you might get confused about which way is easier for which type of problem. Okay? I don't care which method you use, it's whatever you are more comfortable with. You do whatever you need to do. You don't need to ask permission. Still doing okay. Yep. All right. When you have, if you want, you can go grab it. When you have the same base and different exponents, you can just simply add those exponents. So this 2 is still out in front. We're not going to change that part. That's a coefficient. But this is saying there's 3 x's here. This one is saying there's 5 x's there. How many x's are there altogether? Hey, look, 2x to the 8th.
Oh,
Ta-da! I'm going to show you 2 different ways to do number 6, which I'm sure you're like, 2 different ways again. It's whatever you're more comfortable with. Option 1. You can simply add those exponents. So that means x to the 0, which we said anything to the 0 power is?
1.
Yes. Not gonna lie, there was a brief moment. I was panicked a little bit. I'm like, please let it be the right answer. Option 2. What did we say about negative exponents?
Not good.
Not good, so we gotta flip that negative. So we flipped that one that was negative down to the bottom to make it positive. Hey, look, it's the same thing. What happens when it's the exact same thing divided by itself? Ta-da! 2 different things that give you the same answer. Which way do you like better? First way?
First one.
First one? All right, cool. Only works for multiplication. Okay. All right, number 7. Makes it look a lot more confusing because there's parentheses around everything. We are simply doing -4 times 3. What's -4 times 3? -12. And then y to the 2nd times y to the 7th. It just means how many y's are there altogether? Y to the 9th. It is okay to have a negative number. It is not okay to have a negative exponent. Negative number, okay. Negative exponent, big old sad face.
Oh, okay.
Got it?
So 12y over 9 power is the...
-12y to the 9th is your answer. We're good. We don't have to do anything else. I'll put a box around it.
Aubrey Corn to the front office, please. Aubrey Corn to the front office.
Still okay? Heck yeah. Quotient rule. I think this rule is super silly. You can do top exponent minus bottom exponent as long as the bases are the same. You can also just ask yourself, where are there more, top or bottom? How many more? Number 8, what do you think the answer is going to be?
1.
Yep. It's as easy as that. Number 9, we got to fix something first.
Flip it.
Flip just this piece. So this gives us 1 as our placeholder on top because there's nothing left. 2 to the 3rd times 2 to the 1st. How many 2's are on the bottom now?
2.
Try again.
How many 2's are on the bottom?
Yeah. Look at the exponents.
Oh, okay, wait.
You're correct. Sorry.
Wait,
Great answer to a poorly worded question. So that's 2 to the 4th, right? We okay with that? Now, what is 2 times 2?
4.
Times 2?
8.
Times 2. 1 over 16 is your answer. And because I love giving you options, apparently, you could have done 2 to the -1 minus 3. Top exponent minus bottom exponent. That means -4, but uh-oh, we don't like negatives in our exponents. So 1 over 2 to the 4th is how we get that. I prefer the first way, just so I don't mess up my like minus negatives and plus negatives and all that jazz. So what do you think number 10 would be? Yeah. Or you could just tell me the answer.
X to the 8th power?
1 over
Over
x to the 8th. Beautiful. And I kind of already touched on this next part. When you have a power to a power, you multiply those exponents. Think about it like sprinkles. You're sprinkling it into every single exponent inside. So 5 to the 2nd to the 0 power. That means 5 to the 0, which is 1. Yes. I can multiply these exponents here. So this is parenthesis, -3 parenthesis to the second times 3 gives us 6. Is it going to be a positive or a negative? Positive because it's an even. So 3 times 3 is?
9.
Times 3 times 3 is 81. And then you got to do it 2 more times. So you're doing 81 times 9. Oh, 9 times 8, 729. You'll have a calculator, don't worry. I don't expect you to be able to do all of that in your head. And I'm going to just warn you now. I'm really sorry if I got it wrong. What do I do with the next one? Yep, means I got to flip it. So first I'm going to multiply it, and then I'm going to flip it. So that's 1 over x to the 3rd. Ta-da. And the reason I'm going to flip it second is because I want to do this first. I don't want to have to flip a flip a flip. So when I multiply -2 times -3,
That's all the sugar.
-2 times -3. Okay, so this is x to the 6th. Hey, look, no flipping needed. Sorry, I'm trying to get through. Let's see, how much? I'm going to go up until we can and hope that we get through it. All right. Again, we're sprinkling. We can take that exponent on the outside and put it to every single exponent on the inside. But here, I'm missing an exponent. Where am I missing an exponent?
Under the 2? Or under the x?
Both of these have exponents of 1. They are separate. I know it looks like the 3 and the x are attached. You can treat them separately. The 3 is repeated once, the x is repeated once. And now you're going to distribute that exponent in. Ta-da! So this becomes 3 to the 2nd and x to the 2nd. What is 3 to the 2nd power? 9, and then we've got x to the 2nd. What happens when we have a negative exponent?
Flip it.
Flip it. Let's just flip it first. We okay with that step? Okay. Now, this means 1 over Remember that that's a negative 3 to the second and then an x to the second, so those parentheses make a difference. Because what's a negative times a negative? So we have 1 over 9x squared. Now, somebody sounds like they're dying right now. Number 17 is kind of weird because what is being repeated twice? Just the 3. Because there's not parentheses like this. So this means negative 3 times 3. Does that make sense? And then there's an exponent of 3.
Pay in full can to the office.
So if you want, you could simplify this part first. That might make more sense to you. What is negative 3 times 3? Negative 9 to the third power. Which means negative, actually, let's start with the fact that, is it going to be negative or positive? Because negative. Okay, I'm trying. No, it's okay, it's okay. 9 times 9 is 81. 81 times 9 is 729, but it's a negative. I'm like, I'm trying here. No, it's okay. It's fine. Is this kind of making sense?
Yeah.
Yeah?
Yeah.
That negative 4, flip that thing. 1 over xy to the 4th. It means the x is repeated 4 times, and so is the y, because these little exponents in here were originally 1s. You okay with that? 1 over x to the 4th, y to the 4th. So what do you think the answer for 19 is? X to the?
X. Wait. What did you say? To the 9th.
X to the 6th, y to the 3rd. There we go. X to the 6th, y to the 3rd. All we did was, let's see. I think you understand the gist of the rest of it, and guess what? We'll start with this on, what's the next day I see you? Thursday. Okay, we'll start with the scientific notation. It's the only thing we didn't get to today. Got it?
And you said we can leave these binders here, right?
Yes, you can leave the binders here if you'd like. You don't have classes on Fridays. It's just Mondays and Thursdays because some people have an art lab. I am available Fridays during that CTE block, so if you have questions, come on in. Okay?
So we only have 2 classes a week?
Yep.